Hi, everybody. I hope you're all doing well today. So last week, actually, let me just recap what we've done so far. So last week we started off with trig. We just reviewed a couple of things about trig, so your regular triangle trigonometry, and then after that we talked about our trig circle and then the radians, and then we also talked about the idea of revolutions around the circle. So we added plus 2k pi for our answers. And yes, I think that's pretty much what we've done so far. So today we are going to start the new topic, which is the trigonometric functions. And we're going to spend a couple of periods on that, not too many, that being said, because we have after that the trigonometric equations to solve and the trigonometric inequalities. But we're almost done with the year, so that is pretty exciting. So the first topic we're going to talk about today is what is called function symmetry. It's essentially just a property. Some functions happen to be symmetrical. And then we have two special categories of symmetry. The first one is even functions, and the second one is odd functions. And it's kind of one of those weird topics that is just going to happen to pop into some math topic that you study further on. So it's a pretty, it's something that I think everyone should have an idea of what it is. And it also happens to be pretty simple. So let's get started. First type of function is called the even functions, and I do believe that it's kind of easier to figure out what the symmetries are if I just give you examples of them. So we're going to start by giving examples. First one that is representative of an even function would be f of x is equal to x squared. So just your most basic parabola. I'm just going to graph it so we have it visually. So typically in class, I would ask you, all right, we all see that this is a function that is symmetrical. Can you please tell me where the axis of symmetry is? And then somebody, or in this case, myself, I'm going to answer. It seems like the axis of symmetry would be on the y-axis. Let me just highlight that. I hope you can all see that around the y-axis, we have an axis of symmetry for this function. So all even functions, not just x squared, any function that fits within the category of even function is going to have an axis of symmetry. Axis of symmetry is going to be the y-axis. And the y-axis has an equation. It is x equals 0. So yeah, that's it for that. It also happens to have a little bit more of a specific definition, which we can use when I am only giving you a function's equation without necessarily having a graph. So you would know a function is even that's an is. It doesn't look like it at all. Is even if the following condition is satisfied. The function f of x is equal to f of minus x. I'm going to highlight this because it's pretty important. So it looks a little bit abstract. Let me just give you an example so that it kind of makes more sense in your head. So for example, if I give you x equals to 1, we're going to go ahead and find what f of 1 is. So you would just take 1 and put it inside your function. You get 1 squared, so it's 1. Now if I take x equals to minus 1, and I do the same thing, I'm going to get minus 1 squared, which is just 1. So what I want you to notice here is that for x equals to 1 and minus 1, we have the same value. Therefore, f of 1 is equal to f of minus 1. And that should be true for absolutely any x. So for instance, if I took x equals 2, then f of 2 is equal to 4, and f of minus 2 is equal to 4 as well. So because they're both equal, again, this is an even function. So this should work for any x that I pick. And this is kind of obvious because if I take for example, if 1 is here and minus 1 is here, what this property is saying is that they have the same y value. So on each side of your y-axis, you should have the same y value, meaning that there is an axis of symmetry at y equals to x. So it all kind of connects, all kind of makes sense. Now, there's one last thing I want to show you about this is that we can in fact prove that functions are even, or we can use this property that I just gave you in order to find out if functions are even by just using the equation. So for now, I'm just going to call it proof because I already stated it, but you can use that to just find it out. So if I start off and I say, okay, let's talk about f of minus x, you would always start, this is always your starting point. To find out if functions are even or odd. We're going to talk about odds soon. What you're going to do now is everywhere you see an x in your equation, you're going to put a minus x instead. So this is going to be minus x squared. And then we're going to simplify this. So obviously, if you have a minus that is squared, it just becomes a plus. So this is just the same as x squared. And then x squared happens to be your f of x. So you see that in conclusion, you get that f of minus x is equal to f of x, which means that your function is even. All right, I hope that makes sense. Let me know if you have any questions. Now let's go talk about odd functions. So an example of an odd function, I think I'm going to zoom a little bit to have more space. An example of an odd function is going to be x cubed. I don't know if you've ever seen x cubed before. Maybe I showed it to you, maybe I didn't, who knows. X cubed looks like that here. So in this case, if I were to ask you where the axis of symmetry is, because there's some symmetry, right? You can see that you've got these two like kind of branches, one going up, one going down. So they kind of have the same pattern. You have to imagine they follow the exact same pattern as a matter of fact. So where is the axis of symmetry? It's a little bit more challenging. And I'm not going to let you linger too long because I don't want this video to last forever. So if I were to reflect this along the y-axis, what I would get is a branch that looked like that. So that would be an even function. So that doesn't work. But now if you look from this to get the black branch, the black lower branch, so this one here, what you have to do is take this blue branch that I just drew and then reflect it along the x-axis. I'm going to pick a different color. Let's take green. So the reason why I just highlighted both axes is because there isn't one single axis of symmetry for this odd function. There's two. So for any odd function, you would have to reflect around both the x and the y-axis, and then you get an odd function. It doesn't matter the order. If you wanted, you could think about it as being like, okay, well, first I reflect the branch in the first quadrant along the x-axis and get this one. And then after that, I reflect it along the y-axis and get my final one. So it doesn't matter if you do first x-axis, second y-axis, or the other way around. It really gives you the same result. So let me write this down. So the axis of symmetry, it's both the x-axis and the y-axis. Okay. Now, in terms of the equation, so let me pick this back. So odd functions, or let me write it like that. I'm going to look to see what I wrote in the other one to have the same sort. Okay, so a function is odd. Is odd if f of x is equal to minus f of minus x. So notice that the difference between the even and odd definition is this minus sign here. So if you have the minus sign in front of the f of minus x, then you have an odd function. And then if you have the opposite, then you have an even function. The other way to write this down, I'm going to write it two different ways because depending the context, I would use one or the other. The other way you could talk about this, you could say f of minus x is equal to minus f of x. I like this one quite a lot, actually. Let me erase that so that you can see my minus properly. If it lets me. That's better. All right. So now that we know that, let's see what it means. So for example, if I picked x equals to 1. So if I have x equals to 1, then we get f of 1, which is going to be 1 cubed or just 1. On the other hand, if I pick x of minus 1, then I'm going to get f of minus 1, which is minus 1 cubed. And minus 1 cubed, as you know, is minus 1. So if you look at this, what we got is f of 1 is equal to, because that's just 1, right? It's the opposite of f of minus 1. It's not equal to my f of minus 1. That's not true because there's a sign difference. So to change the sign, we would add a minus in front of it. So this is essentially minus 1 now. I hope that you can see that. All right. So let's see if we can prove that this is indeed an odd function. So we have, I'm going to write the proof. I'm going to start off with f of minus x, and I'm going to prove, so I'm going to use a second property. I'm going to prove that this is equal to minus f of x. So if I take this minus x and substitute inside my equation, so it means that this little guy, this x here, should become minus x instead. So this is going to be minus x cubed. Minus x cubed, we don't need brackets for that. You could, because minus 1 cubed is just minus 1. So this is the same as minus x cubed, which is the same as minus f of x, because x cubed is equal to f of x. And therefore, you have proven that f of x is odd. All right. I hope this made sense. Let's go. There's some functions that are symmetric, but are neither odd nor even. Let me move this. And we have to be careful not to confuse them. Sorry for wiggling so much. So I'm just going to give you a couple of examples of functions that are neither odd nor even. So first example, f of x is equal to x minus 1 squared. So again, we have a quadratic. This, if you remember, is parameter h. And parameter h is responsible for moving your function around horizontally. So this function here would be the same as the one we graphed first, but it would have its vertex at 1 instead. So as you can see, it seems like this function is symmetrical, but your axis of symmetry is here. It's in the middle. It's going through your vertex. So because of that, it is neither odd nor even. So it is symmetric. But it isn't odd and it isn't even. Second example, I'm going to give you f of x is equal to 2 to the power of x, function we've been dealing with at the beginning of the semester. It's our exponential function, looks like that. This one is not symmetric, it is not odd, and it is not even. It's nothing. It's just boring. So let's see another example of something that is symmetric but not odd or even. So if I have, or maybe it is, I can't remember what I decided to do with that. Let's see. So x cubed minus 2. So this is the cubic function that I drew in the other example, but it's going to be moved down by 2 units. So it's going to look like that. Again, this is symmetric. It looks like there's some axis of symmetry maybe somewhere, but it's not odd and it's not even. It's a little bit difficult to write on this sometimes. And the reason for that is because it's true in this case that the y-axis is an axis of symmetry, but you would need, it's not perfect. Like you would need your second axis, your x-axis, but it's not true that if you reflect it along the x-axis that it would work. We would need to reflect along the line y equals to minus 2, but that is not the definition of an odd function, so that doesn't work. All right, I hope that makes sense. Now the last thing I want to show you before I finish this video is I want to show you how I want to show you, sorry, English would be nice if English worked today. I want to show you how to find out if functions are even or odd from the equation. So let's start. First example I'm going to give you is f of x equals to x to the power of 6 plus 1. So we're going to use the definitions that we've seen. The f of x is equal to minus f of minus x for odd, and f of x is equal to f of minus x for even. So what I'm going to do is I'm going to go ahead and start with f of minus x, just like I did for the two proofs, and go figure out what that is. So if I substitute for minus x in there, we get minus x to the power of 6 plus 1. That's the same as x to the power of 6 plus 1, which is f of x, meaning that this is even. Second example, if I had x to the power of 5 plus x. So again, you start off with f of minus x. You get minus x to the power of 5 plus minus x. Let's take care of our negatives. This time, there's a little bit of a mistake here, guys. This bracket should be like that. All right, so I'm going to distribute my power of 5, meaning that we get minus x to the power of 5, and this here is just minus x. I'm going to factor out a minus. You get x to the power of 5 plus x. And then what's in the bracket right now is f of x, meaning that we have minus f of x. Therefore, this function is odd. All right, I hope that makes sense. Let me know if you have any questions. Have a great day, guys.